Hello, this Vodcast is an acid deposition, which is also called acid precipitation. And the learning target for this Vodcast is to describe the causes and effects of acid deposition. So what does this diagram tell us about acid deposition? This shows the pH scale. pH 7 is neutral, and that's the same as water. pH 14 is as basic as you can go, which is the same as oven cleaner, liquid drain cleaner. And the most acidic that you can get is pH 0, which is the same as battery acid. Now, if you look at a healthy lake, is just a little bit acidic at 6.5. Clean rain is actually a bit acidic. And the reason why is because when water is going through the atmosphere, it's picking up carbon dioxide, and the carbon dioxide gets dissolved into it and turns into carbonic acid. So it's a little bit acidic. Acidic rain, therefore, is more acidic than that, and you can tell there that it's around 4.2 to 4.5. And there are some acidic fogs that are even more acidic than that. So how does rain become acidic? Well, we learned in a previous podcast that nitrogen oxide combines with water and light to become nitric acid. So nitric acid is a secondary pollutant, and nitric oxide is a primary pollutant. And the nitric acid is an acid, and that is in the rain becomes acidic. Also, sulfur dioxide combines with the water and light, and that makes sulfuric acid. How do they get in the air? And as we learned before, the nitrogen oxide gets into the air through transportation. It comes through the exhaust fumes that come out of the cars and trucks and SUVs, and also from power plants, it's all from burning fossil fuels. Sulfur dioxide are from coal-burning power plants. Sulfur is high in quite a few forms of coal. And here are the different types of acidic deposition. And you see here why I'm calling it acidic deposition and not acidic precipitation. There's wet deposition, which really is precipitation, where it could come down as acidic rain, acidic snow, acidic fog, or acidic cloud vapor. It occurs within 4 to 14 days of its formation, and it's frequently far away from the pollution source. So in other words, that the sulfur dioxide could be released into the atmosphere in Ohio and then come down here in New York City. And then there's dry deposition. And here it's acidic particles of sulfur dioxide gas, sulfate salts, and nitrate salt. So this is not actually precipitation, it's just deposition, it's solids. And this occurs within 2 to 3 days, and it's near the pollution source. A few things about coal-fired power plants, like what you see over here. Coal-burning power plants are the major source of SOx. These 1,000-foot smokestacks, as we said it in the earlier vodcast, they do help lower local pollution by getting the pollution above the inversion layer, and also by helping the higher winds spread it out away from the local area. Unfortunately, these pollutants are easily dispersed downwind. These old coal-burning power plants in the Midwest, they've given the East a serious acidic precipitation problem. The typical precipitation in the East is 10 times more acidic than normal because of these several old coal-burning power plants. You see in the diagram over here that these are the 50 worth largest uncontrolled sulfur dioxide emitters. You see a lot of them are over in the Midwest, and these are areas where they don't have a lot of controls over those. And the areas where you've got the major problems, by and large, in terms of precipitation, are areas where you don't have it because they have pollution controls. Now, if you look at this other diagram, there you see where the acidic precipitation is. And yes, there is some overlap as to where the power plants are, but in places like Ohio, it's actually not as much of a problem, because a lot of the bedrock there is limestone, and limestone tends to buffer the soil so that it counteracts the acid. It's like if you take vinegar, which is acidic, and you add it to baking soda, it's going to neutralize that acidity. Now we're going to look at the effects on various things. We'll start off with the effects on lakes. This here is a picture that I took back when I was at camp, and this is a picture of Lake Auger in the Adirondacks. Actually, it's a picture of my camp. It's in the foreground of the lake, but you really can't see it because it's in the woods. So what happens to the lakes is that acidic water is able to wash the metals such as lead and mercury and aluminum into lakes, and these poison the fish. 45 U.S. states have issued warnings about eating fish because of mercury contamination. Now, some of this mercury is due to acidic water, and others it's not due to acidic water. It's because companies have illegally, or if it's early enough, legally dumped the mercury into the lakes or into the soil, which then gets washed into the lakes. Also, aluminum, which is very common to soils, asphyxiate fish by stimulating excessive mucus, which then clog the gills. Fry, which is another name for baby fish, and eggs are very vulnerable to acidic water. So what happens is that when the acidity goes down in a lake due to acid precipitation, all the eggs and the fry die. So you end up with first just adult fish, which then eventually all die, and then you'll end up with crystal clear waters of a lake with no fish living in those lakes. Now, why would pH go abruptly down in the spring, which is called acid shock? And the reason why that happens is because during the winter, there's a lot of snow in the mountains. During the spring, all that acidic snow melting then gets dumped into the lakes and brings down the pH. The effects of this is that in New York, hundreds of lakes have no fish. There are thousands in Norway, thousands in Sweden, and thousands in Ontario, Canada. And in Canada, 70% of their acid precipitation comes from the United States. So laws in Canada preventing acid precipitation cannot do much to really save their lakes. What has to be done is they have to have treaties with the United States or put diplomatic pressure on the United States to pass laws. Now, the effects on forests. Now, when I was preparing for this podcast, I was looking through pictures that I took when I was young at camp to see if I could see evidence of acidic precipitation, and sure enough, I saw some. If you look at these pictures, particularly the ones down there, you notice how the tops of the trees don't have leaves, and that is a sign of acid precipitation harming the trees. So what happens is that trees have roots near the top of the soil and roots towards the bottom. The roots near the top of the soil are the roots that get the nutrients from the soil, because that's where the nutrients are basically found. Further down, it would just be water. And the acid rain washes the nutrients, or leaches the nutrients deep into the soil where those shallow roots can't reach them. So in other words, these trees get nutrient deficiencies. That's what you just saw in those pictures of those trees. That was a sign of the trees being sick from nutrient deficiencies. And that makes them very vulnerable to stresses such as severe cold, diseases, insect attacks, and droughts. Now, in some areas, like a lot of the Midwest, the bedrock is limestone or marble. Then the soil is buffered against the acid because limestone and marble contain things that make the soil basic. And bases are able to neutralize acids. Effects on farms. Acid precipitation is able to harm crops, especially when it lowers the pH of the soils below 5.1. And this reduces the plant productivity. Effects on buildings. Well, this picture over here is a picture of Cleopatra's Needle. The one on the right is a picture of it when it was still in Egypt, where you can see all the hieroglyphs. And the one on the left is a picture that I took in Central Park, where you can still see it. It's right by Metropolitan Museum of Art. The pollution has pretty much erased a lot of the hieroglyphs. So what the acid does is it corrodes the metals, and many statues, buildings, and monuments which are composed of marble or other stones, and I believe Cleopatra's Needle is sandstone if I remember correctly. Marble and limestones are especially vulnerable because they react chemically with the acid. Now, what are some solutions? One is to reduce coal use. Another is to burn low sulfur coal. Can also increase natural gas and renewable energy sources. Natural gas is far less polluting and also doesn't have any sulfur. Renewable energy sources, a lot of that doesn't put any of these pollutants into the air. Also, you can remove pollutants from smokestacks. We'll be going into a lot of that in a future Vodcast about scrubbers. It's all in conventional energy unit. Pollutants can be taxed. Also improve energy efficiency. When energy efficiency is improved, that means that you're burning less coal for electricity. After effect type of thing, could add lime to lakes and soil to neutralize acids. I know that some maple tree plantations, that's what they do to save the maple trees. Also add fertilizer to replace lost nutrients. Now here is some legislation that helped. The 1990 Title IV Amendment to the Clean Air Act. What this did was that by 2010, sulfur dioxide emissions were to be reduced by 10 million tons to below 1980 levels. So a permanent cap of, or a permanent top level of 8.9 million tons of SO2 is allowed to be emitted. Each utility was given emission allowances, and these utilities are free to choose how they achieve those allowances. Any new utilities that come into existence, they have to purchase existing allowances. So at this point, there are no new allowances that are being given out by the EPA. Everything is capped off so that utilities, if they want new ones, they have to purchase it from other companies. And other companies are able to make them available by not polluting as much. For that, they're able to pollute less by increasing energy efficiency, by adding things like scrubbers to remove the pollutants from their smokestacks or other things. Also, NO2 emissions were to be reduced by 2 million tons by 2001 by regulating boilers that the utilities use. Now, here's what this accomplished. Many utilities are switching to low sulfur coal, and the older power plants are adding scrubbers. It's in the smokestacks, and the smoke that's coming up through it is being sprayed with a solution of lime that basically will neutralize the acids in the smokestack. Many utilities are trading allowances to achieve compliance. For example, they will trade the right to emit 10,000 tons of SO2 at a cost of $200 a ton. So that will allow utilities to pay for and make a profit off of pollution reduction technology. Now, they had two phases for this. Phase one was prior to the year 2000, and for that they were focusing on the worst polluting utilities. And if you look on the graph here, you see how the amount that they were emitting went down quite a bit from 1980 to 1999. And then when you look at in post-2000, that's phase two, and now all sources are being targeted by Title IV. So phase one addresses the worst polluters, and phase two addresses all polluters. And you can see how the amount of pollution that's emitted has gone down quite a bit between 1980 and 2004. The next law are the CAFE standards, and also some other amendments from the Clean Air Act. The Clean Air Act amendments, they mandate emission inspections, catalytic converters, and computerized control of fuel mixture, which allows more complete combustion. And these are in cars and light trucks and other motor vehicles, like SUVs. What the CAFE standards have done is that they've set fuel economy standards for passenger cars at 27.5 miles per gallon, light trucks, which also includes SUVs, at 20.7 miles per gallon. 1974, it was as low as 12.9 miles per gallon. When the engines are more efficient, that means there's less air pollution. If you look at the graph here, that shows the amount of emissions of pollutants by cars from 1965 to 2000. You see how much it goes down. Now we come to our concluding questions. Number one, what are the sources of acid deposition? Number two, how does acid deposition affect forests and lakes? And number three, how has the Clean Air Act amendments helped to control acid precipitation? That concludes this Vodcast, and I will see you in class tomorrow.